Okay, this video is on probability and combinations, which is pretty much like the last thing you do in Algebra 2. So probability is the chance that something can happen. We talk about this in our daily life with the weather or a hurricane or something like that. That's something that we're used to saying. There's a 70% chance of this. It can be used in so many different ways. That's just the one that is the most common to us. So it always represents a part of a whole, which means it's usually a fraction in the math world. It could be a decimal, it could be a percentage, but it's always a part of a whole. Even that 70% is part of the 100% that exists. So some of them are very straightforward. Some of them you have to use a little bit of logical reasoning. Let's give them a try. So, for example, given the numbers 1 to 50, what's the probability that I will choose a number with a 9 in it? All right, so first of all, there are 50 numbers total. Numbers with a 9. Let's see, I have 9, 19, 29, 39, that says 34, 39, and 49. So I have 1, 2, 3, 4, 5 numbers with a 9 in it. So I have, out of my 50 numbers, this is my total numbers, I have 5 with a 9. So I have a 5 out of 50 chance, which is the same thing as 1 out of 10. I have a 1 in 10 chance of pulling a number with a 9 in it from the numbers from 1 to 50. So that's pretty much all you're doing, figuring out how many you have to choose from and what is the chance of that happening. Great. A bag contains 15 marbles, 6 red, 4 yellow, 3 blue, and 2 green. If you pick a marble at random, what is the probability that you will pick? And then you have 3 questions. So altogether I have 15 marbles. So the first question says, what's the probability that you will pick a green marble? So out of my 15, again, this is total, how many are green? I have 2 green. This is a 2 out of 15 chance. What about a marble that is not yellow? Still, out of that 15 total, how many of them are not yellow? Well, I have 4 yellow, so there are 11 not yellow. And the last one is a blue or a red. So this is total on the bottom. On the top, I would be successful. I would choose blue, or if I choose red, I'm going to add those together. There are 3 blues and 6 reds. That's going to be a 9 out of 15. 9 out of 15 is reducible. 3 goes into both of these numbers. 3 goes into 9 3 times. It goes into 15 5 times. So you have a 3 out of 5 chance of getting a blue or a red. Think about it as like a win. I win this game if I pull a blue or I pull a red. Well, there are 6 reds and 3 blues, so I have 9 winning marbles out of my 15 marbles. So that's kind of how you can think of the or statement. Okay. Independent and dependent events, really that just means you're doing more than one thing. Sometimes they rely on each other, like their outcomes rely on each other, and sometimes they don't. So either way, you're just going to multiply their probabilities together. Find the probability of each individual event, and then multiply them together. So a bag contains 12 marbles, or 12 red marbles. Back to the marbles. A bag contains 12 red marbles, 9 blue marbles, 11 yellow marbles, 8 green marbles. I'm writing this out. 12 red, 9 blue, 11 yellow, 8 green. 3 are randomly drawn and not replaced. That is important to notice. I'll show you why. Find the probability that red, blue, and green marbles are selected in that order. So, first of all, how many total marbles do I have? 12, 9, 11, and 8. That's 20 and 20. I have 40 marbles. So I'm starting with 40 marbles right away. Out of my 40 marbles, I need to have a red marble. So there are 12 red. Then I need a blue marble. I do not put that red marble back. I pulled one, so now I no longer have 40 marbles. I have 39 because I just pulled one out. I pulled out a red. You always assume successful. I pulled a red. Now I want to pull a blue. Out of these 39 marbles, how many of them are blue? 9. And then I want to pull a green. I just pulled another marble, so now I only have 38. How many of those are green? 8. And at the end, you just multiply them all together. Now we're going to end up with a pretty large number here. This is why we can use our calculators. So we have 12 times 9 times 8. 12 times 9 times 8 is 864 over 40 times 39 times 38, 59,280. This is definitely reducible. I'm going to divide them both by 2, which I know is probably smaller than I should, but whatever. 2, 9, 6, 4, 0. 864 divided by 2 is 432. Both of those numbers are still divisible by 2. So I'm going to do that again. In 1 moment. I'm going to do that again where I divide by 2. I'm trying to get this, I'm trying to get this to reduce as much as possible. I'm also trying to move this away. Okay, so what I have now is 432 over 29,640. Divide both of these by 2. I get 14,820. I get 216. So now I have 216 over 14820. Again, I'm just choosing 2 because these are even, and that's the easiest way. If you know a bigger number that goes into these, do that. 216 divided by 2 becomes 108. Spending more time doing this than I am the actual thing. 108. And then 14,820 divided by 2 is 7410, still divisible by 2. 7410 divided by 2 is 3705 on top. 108 divided by 2 is 54. Well, they're both not even anymore, so I can't do anything there with the 2's, but I can. This is a 57. Can't read my own handwriting. 37. Wow. I'm going to jump to 3. So I'm going to divide both by 3. 3705 divided by 3 is 1, 2, 3, 5. And 54 divided by 3 is 18. 8, 9, 10, 11. I don't know if 1235 is divisible by anything that 18 is divisible by. 1235 or 18 is divisible by 2. 1235 is not. It's divisible by 3. 1235 is not. It's divisible by 6 and 9, which are also both multiples of 3 and 6, or 2 and 3. So this is going to be the end of the end. There we go. So that simplification process, a lot of times I lose my students there. You guys aren't that comfortable with just picking a number and dividing by it and seeing if it goes into the numbers in your fractions. That's just part of simplifying your fractions. Start with 2 if they're both even. If not, try 3. If it ends in a 0 or a 5, choose 5. There are little tricks you could do, like number sense, that will help you there. All right. What is the probability of rolling a 6-sided die 3 times and getting a 4, and then an even number, and then a number greater than 2? So this is one where your events don't matter individually. You're doing this, and then no change. You're doing it again, and you're doing it again. Whereas before, we weren't putting that marble back. So that's a dependent variable, because every time I didn't put that marble back, something changed. Here, I roll a dice again, I roll the dice again. They're completely independent. I just want to know what is the chance of this happening. So what is the chance that I get a 4 on a 6-sided die. Well, that's a 1 out of 6 chance. There are 6 numbers. 1, 2, 3, 4, 5, 6. What's the chance that there's a 4? 1 and 4. And then out of those 6 numbers, what's the chance that there's an even? Well, there are 2, 4, and 6, 3 evens. And then what's the chance that it's greater than 2? So 3, 4, 5, and 6 are all greater than 2. And what are we going to do? We're going to multiply these together. So I have 1 times 3 times 4, that's 12. 6 times 6 times 6, that is 216. And again, I'm going to reduce. Both of these are even, so I can divide them both by 2. If I divide 12 by 2, I get 6. If I divide 216 by 2, I get 108. Also still even, so I'm going to divide by 2 again. Divide by 6 by 2, I get 3. 108 divided by 2, I get 54. Let's try one more time. Does 3 go into 54? It sure does. 18 times, which means I have a 1 on top. There's another way to do that. If you wanted to, you could do 1 out of 6 times 3 out of 6 times 4 out of 6. And you could watch me simplify differently. Everything on top is being multiplied and everything on the bottom is being divided. So my 3 over 6 can be a 1/2. And then I could take this 2 and put it into 4 twice. Now I have 2 over 6 times 6, that's 36, which is 1 out of 18. So it's whatever way you prefer to simplify that's going to work for you. Okay. If you pull 2 cards from a standard deck of cards, putting it back between each pull, what is the probability that you pull a 5 or an 8 and then a red card? All right, so cards. You got to know a little bit about cards. There are 52 total. 4 suits of each. There are 4 suits in each set of cards. Half of them are red, half of them are black. 2 to 10, and then Jack, Queen, King, Ace. So I have 52 cards total. What is the probability that you pull a 5 or an 8? Well, out of the 52, there are 4 5s and 4 8s. So there's an 8 out of 52 chance that I pull a 5 or an 8. And then, what is the chance that you pull a red? Well, half of the cards are red, so 1 in 2 chance, or 26 out of 52. And then I'm going to multiply. So I end up with 8 over 52 times 2, that's 104. This does simplify. I'm going to divide by 2, not write 2. Divide by 2, and I get 4. Divide by 2, and I get 52, and I can divide one more time. 4 divided by 2 is 2. 52 divided by 2 is 26. Oh, I could do it one more time. 1 out of 13. Good. So you got to know a little bit about cards there. All right, combinations and ordering. This is when you have to make choices or put things in a certain order. So arranging a seating chart, arranging something for a sports team, picking out an outfit, picking out things from a menu, all of those have to do with combinations and ordering. So if you're picking out an outfit to wear today, you can choose from 7 shirts, 3 pants, 4 pairs of shoes, and 2 jackets, one of each item. How many different outfits could you make? What do? You just multiply them all together. Seven times 3 times 4 times 2. So what is this? 21 times 8, which is 168. You have 168 possible outfits from those items. That is as simple as it gets. All right. Amanda's going to get frozen yogurt. There are 5 different flavors, 11 different toppings, 4 syrups to choose from, and 3 different size options. Assuming she gets one of each category, how many different ice cream combinations could she make? I guess it's frozen yogurt combinations, whatever. So she has 5 flavors, 11 toppings, 4 syrups, 3 sizes. Multiply them all together. 5 times 11, that's 55. 4 times 3, that's 12. I do not know this one off the top of my head. 55 times 12 is 660 different combinations for her dessert. Frozen yogurt, not ice cream. So when you're just trying to figure out possible options, multiply all your options together. Whereas this, a coach of 8 players is trying to create a batting lineup. How many different ways can the coach arrange his players? Here, order matters. I have 1, 2, 3, 4, 5, 6, 7, 8 people to put in 8 different places. In the first position, I have 8 people to choose from. Now I've put someone there. I have 7 people to choose from for my next one. And then 6, 5, 4, 3, 2, and 1. This is called a factorial, which looks like an exclamation mark. But yeah, that's what happens when you go down by 1 like that, and then you're multiplying. 4, 3, 2, 1. There are 40,320 ways that he can arrange his players. All right, how many different ways can you arrange the letters in the words Mississippi? All right, so you would think this is kind of the same thing. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters in Mississippi. 11 letters, so this would be 11 factorial, right? Because I have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Now we have to account for one thing. The letters that repeat. You're going to divide by them. I have 1, 2, 3, 4 I's. So I'm going to divide by 4 times 3 times 2 times 1. Because just because you put a different I in a different place doesn't change the word. An I is an I. So you have to take those out. I have 1, 2, 3, 4 S's. I have 4 times 3 times 2 times 1 S's. And I have 2 P's. That's 2 times 1 P's. So now I can try to figure this out. I'm going to cancel some stuff out rather than deal with these massive numbers. So 4, 3, 2, 1, 4, 3, 2, 1. Easy peasy. My ones I can cancel out anyway. I can do it from here if you want, or you can simplify some more. 3 is going to go into 6 2 times. 4 is going to go into 8 2 times. I still have a 2 and a 2 on the bottom. That leaves me with a 4. That's all that's left. That's not circled or canceled out. On top, I have a 11. I have a 10, a 9, a 2 where the 8 was, a 7, a 2 where the 6 was, and a 5. So I could even cancel these out a little bit more. 2 times 2 is 4. So those cancel out. So now I just have 11 times 10 times 9 times 7 times 5. And I'll plug that in my calculator. So here order matters, just like the last one, which is why we count down, except since some things repeat, they would create identical words even though you have rearranged which I goes where, which S goes where. On paper, that doesn't matter. An I is an I, an S is an S. So you have to take away or divide by the repeated letters and then do that process. So you get 34,650. And the last one, a group of kids are playing in a game in which they spin a colored spinner and earn points based off of what color they get. A table with these values is below. Let X represent the number of points awarded. What is the expected value? Okay, so the expected value is what you get when you multiply your probability times your number of points and then add them all up. This would only exist if you're putting some sort of point value or monetary value to a probability. So we'll do this with each one. So I've got 0.35 times 5. I've got 0.21 times 6, 0.14 times 9, 0.17 times 8, and 0.13 times 10. So what I have here is 0.35 times 5, 1.75. 0.21 times 6, 1.26. 0.14 times 9, ooh, 1.26. That's the same thing. 0.17 times 8, 1.36, and 0.13 times 10 is 1.3. And then you just add them all up. I am going to use my calculator. 1.26, 1.26, 1.75. I hit the wrong decimal. 1.26 plus 1.36 plus 1.3. You have an expected point value of 6.93. So pretty much no matter what you get, you should expect a point value of around that, or at least that. Okay, so this is combinations and probabilities and ordering. Good job.